Welcome to the tutorial for the MPLAB Starter Kit for PIC24F. My name is Kim Otten, and I am an Applications Engineer at Microchip's headquarters in Chandler, Arizona. In this tutorial, I will be guiding you through the PIC24F Starter Kit's demonstration project and showing you the powerful features of the PIC24F microcontroller that you can use in your own application. The Starter Kit consists of a software installation disk, the Starter Kit board, and a USB Mini-B cable to connect the Starter Kit to a PC. Before connecting the Starter Kit to the PC, install the Starter Kit software by inserting the CD and following the instructions. The installer program will install the MPLAB IDE, a student version of the MPLAB C30C compiler, the demo application, and the Starter Kit documentation. Let's take a look at the Starter Kit board. Note the vertical white line on the board. The circuitry to the left of this line is an in-circuit debugger. This circuitry allows you to debug an application on the Starter Kit without an external debugger. The circuitry to the right of the white line is the demonstration application. At the heart of the application is a PIC24FJ 256 GB106, the 64-pin member of the PIC24FJ256 GB1 microcontroller family with USB on-the-go capability. 5 capacitive touchpads provide user input to the application. A 128 by 64 pixel organic LED display provides graphical feedback to the user. The RGB LED can produce nearly any color by varying the red, green, and blue components of the emitted light. The USB Type-A receptacle is utilized when exercising the USB embedded host capability, and the Mini-B receptacle is utilized when exercising the USB device capability of the microcontroller. A potentiometer is also provided for input. The PIC24F microcontrollers have many features and peripherals that make them powerful, versatile platforms for embedded projects. The Parallel Master Port, or PMP, is a parallel 8-bit I/O module specifically designed to communicate with a wide variety of parallel devices, such as communications peripherals, LCDs, external memory devices, and microcontrollers. Because the interface to parallel peripherals varies significantly, the PMP module is highly configurable. The real-time clock and calendar module is a 100-year clock and calendar with automatic leap year detection. It runs off a 32.768 kHz input from the secondary oscillator and is optimized for low power usage in battery-powered applications. The Charge Time Measurement Unit is a flexible analog module that provides accurate differential time measurements between pulse sources, as well as asynchronous pulse generation. The CTMU allows an application like the Starter Kit to utilize capacitive touch sensors for user input. The Universal Serial Bus module contains the analog and digital components to provide a USB 2.0 full-speed and low-speed host, full-speed device, or on-the-go implementation with a minimum of external components. USB device mode support allows an application to easily interface to a PC, while USB embedded host capability allows an embedded application to utilize the wide array of available USB devices. An output compare module has the ability to compare the value of a selected time base with the value of 1 or 2 compare registers, depending on the operation mode selected. Furthermore, it has the ability to generate a single output pulse or a train of output pulses on a compare match event. The PIC24FJ256 GB106 has 9 independent output compare modules. Many of the PIC24F devices have the peripheral pin select feature. On many microcontrollers, especially the lower pin count devices, pins are often shared between device peripherals. For example, a UART module may share pins with an SPI module. If an application wanted to use both the UART and the SPI, it would require either special hardware and software multiplexing, or a larger pin count device that does not share those pins. Peripheral pin select allows the user to remap certain digital signals to optimally utilize the peripherals and the available pins on a device. Peripheral pin select also allows peripherals to overlay each other. For example, mapping an interrupt on change input onto a UART receive pin allows the device to wake up from sleep when a character is received. In addition, peripheral pin select allows multiple pins to be used for a single output function, increasing the drive strength. All of these features are available on a device with processing power of up to 16 MIPS, with an architecture where the majority of instructions are executed in a single cycle. Now let's take a look at the demonstration program already loaded on the PIC24F starter kit. After installing the software on the CD, plug the starter kit board into a USB port of the PC by plugging the Mini-B cable into the receptacle on the left side of the starter kit board. Allow the pre-programmed demonstration program to run. The starter kit will display a splash screen and set the RGB LED to a series of different colors. After the introduction, the organic LED graphics display will appear as shown. The OLED is controlled via the parallel master port. The demo utilizes the microchip graphics library to control the OLED and create various controls on the display, such as buttons, pictures, text, and sliders. The touchpads to the right of the display implement a capacitive touch sensing for user input. The touchpads are connected to analog inputs to utilize the capacitive time measurement unit to detect a touch. Use the arrow touchpads to change the highlighted button, and use the center touchpad to select it. The date and time at the bottom of the display are obtained by utilizing the real-time clock and calendar. Since the starter kit has no battery backup, the initial starting time is hard-coded. You can change the time and the date through the demo application. Use the left, right, and up-down touchpads to highlight the Utilities option, and then touch the center touchpad to select it. The different utility functions of the demo are displayed. Use the touchpad to highlight and select the Date/Time option. This portion of the demo allows you to set the current date and time of the RTCC. The current parameter is indicated by a thick outline. Use the left and right arrows to select which parameter you want to change. Touch the up arrow to increase the value, and touch the down arrow to decrease the value. When all parameters are set, touch the center touchpad to return to the main menu. Microchip has expanded its USB offerings with the PIC24F 256GB1 microcontrollers. Like the PIC18F devices, these microcontrollers provide USB device functionality, allowing an application to have easy connectivity to a PC. In addition, the PIC24F family also offers USB embedded host capability, allowing an application to utilize a selected subset of widely available PC peripherals, or to interface with a custom device. An advanced application can be a USB dual-role device by acting as either a device or an embedded host. In addition, the PIC24F devices support USB on the go, which allows an application to switch roles on the fly without manually changing cables. The starter kit's demonstration application shows the USB embedded host capability of the PIC24F 256GB1. From the demo's main menu, select the Flash option.